Hi and welcome to the lab. This is Nina 6502, the computer I've been working on for the last month or so. Quick run through. We have 6502 processor there. That's capable of 14 megahertz, but currently it's running on an 8.192 megahertz CAN crystal there. That's a 32K by 8 bit ROM. RAM. That's the ROM. It's 17 nanoseconds. It's 32K big, although only parts of that are actually used, which does leave up some area for I/O, which we shall discuss a little bit later on. It is an actual ROM as opposed to an EEPROM. EEPROMs weren't fast enough for running at 8.192. I didn't want to go to the 100 nanosecond EEPROMs because it was cheaper to actually buy a one-time programmable ROM. These chips along here, or Glue Logic. Apart from that one, which is actually an oscillator that runs the baud rate, or at least the divisions of the baud rate for this chip here, which is a 4040 divider. That's just a plain old hex 6 by inverter, running at 9.8034 megahertz. And so of course you get all your divisions there for your baud rate for the RX and TX on the 6850 ACIA chip here, which is really nice because you can select the baud rate for transmit, the baud rate for receive completely separately, which is what is being done here, because the input to the computer is done with a PIC chip, which controls the USB keyboard. So that is in effect, the PIC chip is the keyboard handler, and that translates from this USB keyboard. There's your wire going in. Just a standard off-the-shelf USB keyboard, no modifications done. The PIC chip is an 18F4685, which has got 48K words on there, or otherwise marketed as 96K. It isn't actually 96K, it's 48K in words. And that's bit banged. What I've done is taken the data signals from the USB, bit banged it to convert to serial at 2400 baud, that goes into the ACIA, goes through the basic ROM into the processor, etc, etc. Right, next we have the video out. You're probably wondering what this is doing there first. That is just a serial port, USB to TTL serial, and that allows me to debug and do quite a few things a little bit later on, which I will discuss a little bit later on. Now then, that's the video chip. It's actually an Atmel 328p, running at 16 megahertz, and that's doing all the video encoding, and that's running at 76.8, or whatever double 19.2 is. No, hang on, whatever double 38.4 is. I think that's 76.8. So that's running at 76.8 serial in from the ACIA here, and giving me video output. Now then, these here are 74245s. These are buffers. Thus far, the computer itself here all works fine as it is, but if you want to do too much more with it in terms of input output, then you're going to be creating greater load on the CPU, its address and data lines, and it might not have enough in terms of milliamps syncing and sourcing to drive extra chips. So what we do, basically, we just buffer them. So there we go, that's the the low 8 address, the high 8 address, and of course the 8-bit data lines. Right, now then, this chip here is also RAM. It's an 8K by 8, which goes with the 32, giving a total of 40K of RAM. Right, next we have, I don't know whether anybody can, if I turn around, will you recognise that number at all? Sure, some of you will. But anyway, that's a Commodore SID chip for the sound, and I've also mapped it in via the one of the address decoders, because that's the primary address decoder, another 74138, and of course one of those lines then goes to the gate input of this 74138, so that I can map this SID chip in exactly the same place that a Commodore 64 maps its own SID chip in. Now what happens at that point is that any of the Commodore 64 programs that run in BASIC, I can type in to the computer, and the same peek and poke statements will work using this. And of course that's the 1 MHz crystal that drives that. Also for the high voltage line, which likes about 12 volts, I've got a couple of DC to DC converters there, and they give me the 9 volts out required to run that. They both take 5 volts in parallel, and then I just parallel up the two outputs to generate the 5 volts. Right, next, there we have the board switcher. Now what that actually does is, as you notice from here, the PIC chip and the keyboard, now that works at 2400 baud. The video chip there works at 76.8, all thanks to this 6850, which does a marvellous job of running different RX and TX boards. However, without any further I/O, what this actually does is switch those out so that the keyboard's cut off, the video chip's cut off, leaving that then completely free at 2400 baud for external storage in terms of I/O. I don't know if you can hear, like, I've got a load of kids playing outside, so just ignore that. Which allows 2400 baud for I/O from solid state memory, which I've kind of half designed. I haven't built it yet, but what that will do will allow me then to via a PIC microcontroller read a 512 by 8 chip that will then be selected up into banks of 64, so I'll get 8 lots of 64 on the 512 chip, and I'll select drive 1, and that will then convert the contents of that RAM chip into serial data at 2400 baud that the computer's going to think I'm typing really quickly from the keyboard, and then load that program in. Of course, if I want to save, what I would do is just literally type list in BASIC, and then of course that would then store onto the RAM chip as it passes the serial data from the 6850 via the PIC into address and data lines that will then transfer into the RAM chip. Of course, none of this is built yet. I'm going to have to do this in 2 parts when I can actually show you when I fire it up, but I'll just do that for a second. There's a 5 volt line, and we are actually on here. I don't know, just give me a second. We are actually on. That's the monitor output. What I'll do is, actually, if I just go back to there a second, just press the reset. As I press reset, whoops, as I press reset, I don't know whether anybody can actually see this, it's saying options, cold start, warm start, or monitor. So we'll, I don't know, go for monitor. We'll press M on this. Right, let's list something in memory. start at 0 0 and we'll go to F F F, and away you go. Right, now then, as you can see, that's all listing out to a computer terminal. I'm running PuTTY at 2400 baud. That's all coming out at 2400 baud, and basically it's just reading through RAM at the moment. And the numbers that you can see in there are just what it uses to calculate the size of the memory when you first fire it up. In fact, a lot of parts of that are going to be just random data at the moment, because we did a straight into monitor, and so it's not trying to work out any sort of memory whatsoever. Right, okay, now I'm just pressing the letter A there, and then B, C, D, E, F. So what the keyboard handler is doing here is converting USB to not just the serial but to parallel. Now we'll get back to some interesting stuff in a little bit, but I've got to shut down for now because the battery's kind of going funny. Bye.